Hello everyone. It's May the 7th. All right, May the 7th. Let's get to it. I mean, today was a good day. I was still doing a lot of data analysis. I was getting some positive results that I think I can argue for, but I'm not gonna bore you guys with the details. But I kind of see the light at the end of the tunnel for this thing, for whatever the project I'm currently working on. Anyway, to take a break, let's take a look at this. Let's see what do we have here. Delete operation of for two strings. Given two strings, return the minimum number of steps required to make word 1 and 2 the same. In one step, we can delete exactly one character in each string. One step to make C into one step to make this LeetCode, we need to delete 4 L, E, and DE. Okay? Lowercase English letters. Dynamic programming. That's my first thought. Use the example see and eat. So we have positions on the first one, we have position on the second one, right? So basically, we're saying the remaining has to be the same. Say I delete the minimum number of steps required. Okay, so we can delete from both words. I mean, the most naive one would be delete 1 from the first and then compare. Doesn't work. Delete from the second. Oh, no. Naive is not going to work. Oh, there's a lot of possibilities out there. So, I mean, if I delete, so basically we can say we delete, let me think, these are index, right? Was it delete an index here and delete an index here? That could be like non-index, which means we don't delete anything. And we can compare, and then we say delete 2 index, or what if we need to delete like different things? How about think about in reverse, right? What is the maximum, minimum number of steps will equal to the maximum. So if we get these two the same, right, and say the maximum number of letters that any substring, not substring, subsequence, the maximum match of the subsequence. And then from there, we can compute how many times we need to delete. So like for C and eat, we say we have EA and EA are the same. It's the maximum that we can find. So for the C, we need to delete 1. For EAT, eat, we need to delete 1. So the answer is 2. For LeetCode and this, we say the maximum that's equal is this and here. So this is basically the maximum matching subsequence. Finding the matching subsequence, the maximum matching subsequence of these two, and then the delete is just, so this is okay, so it's a maximum subsequence problem, which I have solved before, which I don't remember how to solve. Oh man, this is a classic dynamic programming. I gotta remember all these things are solved. They can be used as tools, right? So maximum subsequence, if I remember correctly, we can build it from front, right? So we say if the first one is the same, then we move on. If they're not the same, so they either could be, right? So if they are the same, if they're not the same, the length, right? We only want is length. So if they're not the same, then either we do a cross match. How do we do cross match? Ah, shoot, I forgot. Damn it. All right, so I think ideal is we have also a dummy, right? So we're gonna say want to match S and E, and they're not the same, so the result will be maximum S in the front and E in the front. Okay. Oh, okay. I kind of remember. So it's gonna be a DP table. Let's just do this one, right? A DP table, and it's gonna be 4. We need 4, right? So we're gonna be 0, 1, 2, 3, 0, 1, 2, 3, and then the 0, first row and the first column are all zeros, right? So when I compare 1, 1, we'll do 1 index starts at 1. Let's consider these two as 1. So 1, 1, if they're the same, then we plus 1 and then move on. If they're not the same, then at 1, 1 position will be maximum 1, 0 is 0, 1, which is 0. Then we move on to compare. So hold on. 1, 1. Now let's keep this and moving this, right? So gonna be 1, 2, 3, 1, 2, 3. So it'll be 1, 2, 2, 1. Right? 2 and 1. Oh, 2, 1 matching. So we say 2, 1 is gonna be 1. 2, 1 will be 1, 0 plus 1. So 1, 0. Okay, which one is row? Which one is column? Come on, man. Column will be eat, and the row will be eat. So we are at 1. Column will be C. So be 1 be 1, 2. Yes, 1, 2. 1, 2, 1, 2 will be 1. 1, 2 will be 1, 0. What's 1, 0? Yeah, 1, 0 is here. 1, 0 plus 1, so it's gonna be 1, right? And then we're gonna move on. Go to 2, 3. 2, 3 is matching, so it's 1, 2 plus 1. So 2, 3, we want 2 plus 1. And then we end, right? No. I don't think that's how it's done. No. So we do 1, 1, and then 1, 2, and then 1, 3. 1, 3. 1, 3 is not the same, so it's going to be a max of 1, 1, a max of 1, 2, and 3, none. So 1, 2 is 1, so 1, 3 is 1, right? And then we're going to do, start with 2. 2, 1, 2, 1 is 0, 2, 2, 2, 2, 2, 2 is going to be 1, right? 2, 2 is going to be 1, and 2, 3, 2, 3 is going to be 2, right? And then last one, 3, 1 is going to be 0, 3, 2 is going to be, oh, sorry. And 3, 2 is also going to be 0. Cross. No, it's not 0 because 2, 1 is, 2, 1 is, how does 2, 1, 2, 1 is 0, so it's 0. And then 3, 3 will be consider 3, 1 and 2, 3. 3, 1, 2, 3, that's 2. Right? And then we return, the result we return is 2. So 2 is the maximum subsequence. So yeah, I think this one shall be correct. Okay, let's take a look. Oh, I also found something interesting today. I need to renew my passport. and I need to take, passport pictures. But I don't want to go to Walgreens or CVS to do so, because I think a previous time when I went there, and it could be just me, unlucky, I never got a physical copy of the digital picture. So I decided to take one myself, and I did. And after taking it, I can upload onto some online service, and they will change the background for you. So the background requires to be white, and it will change the background. Some Adobe magic to identify where your face is, or where your hair, and that they crop out that, and then they turn the background to white, and then they blur the edge of your, like the outside silhouette. They blur it a little bit, so overall the effect looks pretty good. I might pay for that, and I want to see how that one goes, if the picture will pass the passport. We'll see. All right, so word 1, we want it to be the column. The word 2 want to be the row. Doesn't matter which one's column. So dp is going to be let's start with 0 times, this has to be, okay, let's do this. So word 1 is column. Column is going to be n. Len word 1, len word 2, right? And no, we have column. N is column, right? And then we say no. Say for this range. We need to plus 1. Right? Okay, so that's the DP column and then row. And then we say for I in range M, I in range M, for J in range N, right? We say if, actually we're gonna say 1 to n plus 1, 1 to n plus 1, right? And if what? If word 1, I minus 1, equals word 2, word 1 is column, so I think this is J. Word 2 is I. Right? Word 2 is I. So if they're the same, then we say dp I j equals dp I minus 1 j minus 1 plus 1. Right? Else, and dp ij equals the maximum of dp I minus 1j and dp j minus 1 I j minus 1 I j minus 1. Right? So we run this. After that, we got the result. So we're going to return, right? Let me say max len equal to max match len equals dp minus 1 minus 1. It's actually dp minus 1 minus 1 is easier. So we're going to return, basically it's n minus, so n plus m minus 2 times dp minus 1 minus 1. Alright, so we're gonna do this. I'm gonna say I'm mixing the Vim and my thing. I'm mixing them together. It's just the Vim thing and just not working for me. It's not, man. It's not working for me. It's so much easier. Like we can use arrow keys when I'm in the input mode. I mean, it's otherwise I don't really know how you can do it without using arrow keys in the input mode. Result is 2. And this one is LeetCode, and ET echo, and the result is 4. and but sometimes it's sometimes it's fine, right? To move around faster. So I'm gonna say word 1, word 2. Like I do like the CE. I like that. Mean distance is gonna be word 1, word 2. Right, try it. Pass. So submit. Pending. Judging. Yep. So yeah, we did judge this question correctly. All right. Well, this is essentially finding the max length of the matching subsequence. Yeah, max length of matching subsequence between word 1 and word 2. Once the max matching length is found, the answer is the sum of the difference between the length of each word and the max matching length. The tricky part is to find the max length, the max matching length, which itself is a classic DP problem that I have learned in class and done in LeetCode for many times. So it would have been a true vergüenza if, I think I spelled it wrong. How do you spell vergüenza? Vergüenza. No, I think I spelled it right. Oh, no, I spelled it wrong. It has to be an accent here. And not ganza. It's guenza. So it has to be a two. No. Vergüenza. Yeah, it would have been a true vergüenza. Being una vergüenza verdadera if I couldn't write the solution in the first try. But fortunately, I did not disappoint myself today. All right, let's see. ON squared, ONM, right? And it's 264 milliseconds or 90. Ooh, okay, 90% ranking. Yeah, it doesn't really matter. It's a good one. I mean, they just add a little bit twist to it, right? Which question it is? It's a medium question for sure. Yeah, it's a medium question. Oh yeah, and I started using the. I mean, like the trackpad as well. I mean, Vim is good. Yeah, Vim is all good and stuff, right? But for me, it's just a combination. I mean, the goal is to find the best tool to solve your problem, and the best tool is the combination of Vim in an editor where it's pretty hard for you to move around, and also using the arrow keys when you're in the input mode. I think that is the best. Longest common subsequence. Oh, that's the word. Longest common subsequence. Length of longest common subsequence. Okay. Why would it be time? Why would it exceed time? I don't understand. Oh, with memorization. length, the max length of longest common subsequence. Once the max, I just call it max length. Yeah, I just call it max. So max length is found. Yeah. Of course, a timeout if you don't use the correct way. For memorization is fine. It's the same. This is dynamic programming. Memorization is a type of dynamic programming already. I think it's just explaining the whole thing again. Like if they're equal, then you do this. If don't match, then we find the maximum of the previous match, right? Up to the current indices also remain the same. We don't pick. We just compare them and then pick the one. Yeah, I think it's the same, right? Yeah. I still remember. Yeah, it's good. I still remember. Without using LCS dynamic programming. The min. There's always 1D. Yeah, there's always a 1D. I mean, if it's 1D, oh yeah, it is 1D because you're only using the information in the like previous row, so it is 1D. Do I want to do a 1D? I don't know. Let's see this one. This one is a direct use of DP to solve it. So it's the same idea. If they're either one is 0, and I don't have to consider this, it should be yes. So yes, that's the number of things you have to delete. Yeah, and then if they're equal, right? If they're equal, then it's the same. Yes, which means if they're equal, then the number of deletion is the same as the previous one. If they're not equal, then will be the number of deletion previously plus 1. Yep, and a minimum. Oh, that's good. Very good. Very, very good. Very good. Yeah, this could be solved like straightforward. You don't have to turn around, right? You don't have to use the longest common subsequence. You can just directly use DP to solve this problem. Yes, that's pretty sweet. If they're equal, then we don't have to delete anything, so it equals previously. If they're not equal, okay, that's good. And all of these can be also solved using a 1D array. Yeah, it can be solved using 1D array. All right, what do we do now? I think what we can do is, oh man, max this plus, oh wow, it's a one line. Let me see if it's one line. Yeah, it is one line. It is one line. Good lord. Nah. We can do. Yeah, let's just write it. I mean, it shouldn't take too long. Get into this mode. Actually, come here. All right. Oh, we also do. Yeah, I mean, I talk about speed. I feel like this is faster for me, right? So we say this is from the official solution, directly using DP to solve the problem. All right, so everything's the same, and then this is the same, and then we actually have to go from 0. All right, we have to go from 0 because yeah, we have to go from 0. So to go from 0, just say if I is 0 or j is 0, right? Either one is 0, then dpij will have to be equal to I plus j, right? Which means if one is the empty string and the other one is a full string, then the result is the full string because that's the number we need to delete, right? And then, of course, we can say elif is equal, then that will be equal because they're the same, then we don't have to delete anything. And you can keep moving on. Else they're not equal, and then it's actually the minimum number of steps, the minimum number we need to delete previously plus 1 because we need to delete one more. And what we return is return this. So we'll go solution 2, pass. Right? Let's just put it in there as well. And we also want to do, I also want to do a 1D. We can try a 1D. So let's try a 1D based on this. Right, so we say solution 3, and can be 1D DP using the longest common subsequence method. So this is going to be what? 0 times column, right? And these are the same. And then say if it's the same, right? If they're the same, let me think. So it's the one, so it's going to be the previous one, right? The previous one, because, hold on. If they're the same, then we say it's -1, and then -1, both -1, like pointing this. But haven't we already updated? Yeah, we already updated. Can we just say -1 plus 1? Hold on. Do we need a separate? Do we need another one? I mean, how can we have to walk from back to front? We cannot go front to back because to go front to back, it's already modified, and we have to use something that's not modified. So we have to go from back to front. So from back to front, right? So every time what we go is going to be, if they're the same, be this and be this one, right? Which is this one, haven't been modified yet. If they're not the same, that's going to be this one, or this one. How does the 1D work? I mean, itself, that's fine. But if the array is recording the previous row, then the current row, hold on. How can you do 1D? Where's 1D? Oh, there's a temp. You have to use a temp. And I was like, there's no way that you can do it without using a temp. Right? You have to use a temp. That's a previous row, and the temp you will store your current row, and yeah. And I think somebody say you don't need a temp. A single int. Ooh, really? Okay. How? A single int. So before I want to check this. How? A single int. Hmm. Current equals DPI. So before we start, oh yeah, before we start, that's true. Before we start, the value is the DPI minus 1, J minus 1. We take it out, and then we do it, and then we say if it's good, if it's not good, right? If it's the same, then we use the value that we took out, right? The value we took out. Because the value we took out is the current, is the, yeah, before we, hold on, no, hold on. Because we updated already, right? If we do this, we'll update it. How do you figure? Oh, is it JavaScript? My God. We have a last TP0. It's hard for me to wrap my head around this. Okay, so we're starting from here, right? We're starting from this, and we're gonna go from the column one by one. And then if it's the same, then we need to have, we want to have one row, right? So we're gonna here, so this is the previous. This is, so these two are good, but we also need the I minus 1, the J minus 1. So we can get the I minus 1, J minus 1, which basically is also the left one, right? It's the left one, and then we can get it, and we do, and that's basically the same, and then we get some value, and we update it, right? We update it. Now we go to the next one. Now the next one has not been modified yet, right? Has not been modified yet. So we take this value out, right? Take this value out. So at every time we visit a cell, right? Every time we visit a cell, what we need to have the previous cell value, the previous cell's previous cell value, and we have current cell value. No, we have the unknown, the one to set, and we have current cell value, which represents j minus 1, j minus 1, and we have the previous value, which represents I minus 1j, and we have something stored, which is the previous iteration of I minus 1j, j minus 1, which is, yeah, so we have 3, blah, 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 we done, and we need to, before we do, we have to save the current value, because that is I minus 1, j minus 1 for the next iteration. But how do we? Yeah, we save that. So we go to the next one, and that, right? And this one's changed. Okay, I think it's possible. I think it's possible. Let's try it. So we have this, right? We have this. That's correct. And then before we go inside, before we go inside, we're gonna say we call it. What do we call it? We call it. Don't look at this. Don't look at this. Let's try it ourselves. What do we call it? We call it I minus I I minus j minus I minus j minus. That's hilarious. That's hilarious. This is going to be dp0, right? Then we go inside, right? Then we go inside. So we say every time we go inside, we're going to take out the current value, right? When we take out the current value, so we take out the current value, right? The current value is going to equal to dpj, right? This current value is going to be this later on. Okay, now we say if this equals this, then dpj equals I minus j minus plus 1, all right? Else, we say dpj equals maximum dpj and dpj minus 1. All right? And after all this, we need to do I minus j minus equals current. And then it's going to be this. All right? Give it a shot. Ay. What the hell? List out of range. Oh, yes, of course. Because it has to be plus 1. Nah, that's nice. Using the LC method, it's quite tricky to wrap my head around. But this post helped. Can we copy this? Yeah, and share. Yeah, but this comment helped a lot. Right, I'm gonna leave a comment that's with here as well. Apply. This is a bit hard for me to wrap my head around, but once I did, how should I say? But it is truly brilliant. All right, so basically the idea, I'm going to say the basic idea is to save the dp I minus 1, j minus 1 before making change to the current dpj, because the current dpj is going to be the I minus 1, j minus 1 is going to be it's a missing match. To just say call. Let's say like this. That's fine. To be this to be this for dp j plus 1. So we take it out. first to prevent its value being modified. Then we do the normal stuff, the normal DP stuff, and at the end, yeah, then we do the normal DP stuff. Yeah, take a while to go through the code if you get stuck. Yeah, this is good. This is very very smart. Oh, I think I forgot to say V. Okay, let's try this one. Now our last one for today. Then we will call it a day. Submit. Yeah. Oh, this one's actually the fastest. I mean, of course, because it's only one array. Yeah. All right. Good. We did pretty well today. A good question as well. All right. That's it. That's it for today. I will see you guys tomorrow. Adios.